Every minute, billions of users log on, click, comment, and share. This creates a massive, continuously updating map of individual behaviors and connections. Professional research guides now categorize these platforms as primary information sources. When posts represent first-hand accounts of events, opinions, or behaviors, they provide the direct evidence required for modern intelligence gathering. Each interaction generates structured telemetry. Every post carries specific embedded metadata, unique user IDs, precise timestamps, geographic coordinates, and connection ratios that allow for systematic analysis. There is a strict caveat to using this telemetry. This data only qualifies as authoritative evidence if the investigator applies rigorous verification protocols to authenticate the source and the content. The modern analyst's greatest challenge is no longer finding information. The challenge is building an architecture capable of filtering ground truth signal from an infinite ocean of noise. To manage noise, investigators rely on a 4-phase intelligence funnel. First, define the objective's exact parameters. Then, identify the specific digital communities holding that data. Next, apply systematic search logic for extraction. Finally, execute cross-verification using 2 independent sources. This systematic approach replaces the outdated method of scrolling through timelines and relying on platform-curated algorithms to surface relevant information. By enforcing this rigid sequence, researchers maintain their objectivity and prevent cognitive overload. The investigation is driven by logic rather than algorithmic distraction. Executing the extraction phase requires forcing the platform's database to yield specific, hidden information. Analysts achieve this using advanced Boolean operators. By manipulating search syntax, like typing cite linkedin.com in title marketing manager minus salaries, investigators filter out millions of irrelevant pages to isolate highly specific professional targets. Once the targeted data is extracted, the next step is assessing it quantitatively using native platform tools. This dashboard shows the Facebook Ads Manager audience overview. Tools like this aggregate single micro-level interactions, individual posts and clicks, into sweeping demographic datasets. By checking the age and gender distribution charts, an analyst can immediately segment a target population and verify if a community's makeup matches their research hypothesis. If the analyst moves down to the lifestyle section, they can see how underlying algorithms cluster user affinities, like purchase behavior or brand loyalty, into actionable behavioral metrics. While tools like Insights provide this account-level data, analysts also deploy macro-level sociological tools, like Facebook IQ, to spot generational behavioral trends across entire geographies. To complement static datasets, analysts also monitor live video features. These broadcasts capture unfiltered, time-stamped primary evidence of events as they unfold on the ground. Navigating these distinct interfaces, from Boolean logic to audience clustering, turns a standard media consumer into an active intelligence gatherer. But manual extraction has physical limits. A human analyst cannot manually track patterns across the billions of signals generated every hour. Automated natural language processing systems bridge this gap. This software rapidly scans and evaluates text, categorizing posts by tone and topic in milliseconds. Agentic AI tools can monitor hundreds of millions of websites simultaneously, performing automated sentiment analysis and mapping conversations across multiple networks at once. Modern systems now process data across 150 million websites in 187 different languages to build complex behavioral models. By analyzing how narratives spread, analysts can forecast specific trend escalations up to 90 days in advance. These models analyze network topology, plotting the exact pathways a conversation takes. They also measure sentiment velocity. By calculating exactly how fast public opinion is changing, the system can estimate the specific moment a social trend will peak. Analysts apply this predictive telemetry to model real-world outcomes, forecasting retail consumer demand, predicting stock market movements, and identifying geographic disease outbreaks based on health complaint clustering. By integrating natural language processing, intelligence gathering transitions from archiving historical events into operating a forward-looking predictive engine. However, predictive telemetry contains a severe vulnerability. If the system absorbs deepfakes and coordinated misinformation, the resulting forecasts will be entirely inaccurate. To defend against this, investigators deploy a mandatory 6-step verification workflow to authenticate the data before it enters the model. The workflow begins with manual checks, conducting an initial claim assessment, verifying the source's credibility against media bias charts, and executing reverse image searches. This is followed by systemic checks, performing network analysis, corroborating findings across platforms, and submitting text to AI evaluation tools for a final review. Because human fact-checking often takes hours, systems also utilize deep learning transformer models that can detect falsehoods at scale in real time. This map illustrates a network topology scan. Analysts use it to spot coordinated, inauthentic behavior, isolating unnatural clusters of accounts that show synchronized posting patterns designed to game the algorithm. This engagement anomaly detection looks at specific metrics, evaluating an account's creation date, its ratio of followers to followed accounts, and its overall posting frequency to determine if a human is actually behind the keyboard. A predictive AI model relies entirely on this verification engine. Without rigorous, automated defense protocols, a powerful tracking system will just scale lies. When you combine these three components, Boolean extraction, predictive AI, and rigorous verification, you build the complete, modernized intelligence architecture. Raw, unstructured social noise enters the funnel on the left. Not data is first targeted and filtered by human Boolean logic, then modeled by AI to extract behavioral trends, and finally scrubbed clean of anomalies by the verification engine. What emerges on the right side of the architecture is a verified, highly actionable intelligence report. Unfiltered social media is a liability for research, but systematically filtered social telemetry provides the most comprehensive and direct primary source data available. Modern algorithms are highly efficient at processing data and flagging anomalies, but it requires human methodological rigor to define the specific objective, select the correct parameters, and interpret the actual stakes of the findings. True intelligence superiority requires this exact synthesis, transforming raw social data into a verified, forward-looking intelligence asset.